This screencast will demonstrate the installation of CSAP using the latest CSAP Docker demo image. Refer to the training section for related screencasts on using an SSH terminal to complete the installation. To get started, we'll navigate to the Docker container setup steps. We'll select the text and then we'll paste them into a console. Here you can see that we're logged into CSAP Dev 20 and that Docker is installed, up and running. So in the terminal, we'll just go ahead, paste the command and hit return. The CSAP Docker image is pretty compressed, and so rather than let it take too long to download, we actually run the installation as part of the startup of the image itself. While this can be a little bit time consuming, it should be completed within a minute or two. This is also useful because it will also show the steps that are involved during the setup. So keeping an eye on the console output will actually give you an outline of what's actually happening to the OS. Once the output on the screen switches over to JSON mode, we are now in the final stages of startup. Like I mentioned, this took about 30 seconds to complete. And so now we can go ahead, open up a new tab, and go to the CSAP agent URL. The Docker demo is set up to run on port 9011. So we've opened up the page, and now we can log in using the credentials mentioned during the CSAP install. By default, this is simply CSAP and CSAP. Since I've been using SSH in this environment previously on my browser context, I'm going to switch to the SSL and then go ahead and log in. To learn more about using the CSAP demo Docker image, refer to the screencast section. Today, we're just going to focus on the installs, so we'll switch to the command runner. As covered in other screencasts, the CSAP command runner enables the execution of shell commands on one or more hosts. In this example, the default template is loaded, and if we hit run, it'll simply output the host name and some other summary information. The installation templates are available in the library, and we can filter these simply by typing install. In this instance, we are going to run the CSAP host install template. To get started, I'm going to quickly update a few of these fields. While this was previously going to default, I simply made it a little bit clearer for this example by eliminating the bash shell semantics. Now I've selected the nodes that I'm going to perform the installation. In this instance, I'm going to perform the installation on 6 nodes. All of these nodes have the same root password. This is important as SSH pass is going to be used to perform the logins concurrently on all 6 nodes. Now by default, all of the nodes would be installed with the CSAP default, meaning they'd be unclustered and essentially 6 standalone nodes. By uncommenting line 39, we are going to leverage a CSAP autoplay template. This will install Kubernetes, Docker, as well as an NFS server to provide storage. The Docker image that's running the demo example we're logged into will actually be the source of the distribution. Therefore, it's critical that you're using a real host name that is network resolvable from the host being installed. Scrolling down a bit in the install script reveals exactly which file is being used. In the highlighted region, CSAP folder refers to the installation folder. We can quickly verify this by switching to the file manager, opening the CSAP platform folder, opening autoplays, and here are all the autoplays that are available. Double-clicking on the demo autoplay reveals the installation template that will be used during the setup of these 6 hosts. The variables that are referenced in this file are updated in the installation script. So if we switch back, you'll note where this is being done. And that's it. We can now go ahead, click Run to start the installation. As mentioned, SSH pass is going to be used to perform the installation on the designated host. Since SSH pass isn't available yet, step 1 will be to actually install SSH pass on the Docker client. We can see that that's completed. Tests have been done to ensure that the new hosts being set up are available and the password is correct. Now the installation will kick off. In this case, you can note that the targeted hosts are all running the latest version of Rocky Linux 8, which is a Red Hat CentOS variant. It is worth noting that the scheduling of the installation is done concurrently, or is done sequentially, but then the actual installs are run in the background on each node. After a couple of minutes, the install will have completed on all of the nodes. So the install on each host takes a minute or 2 to complete, but we should see the agent shortly. And after a minute or 2, the agent is available on the first host. As mentioned before, the template being installed includes a lot of items. And so you can see that Docker is being installed on 7. That said, we have already installed many services while I was a little bit slow getting in today. If we switch to the Services tab, click on Csap Admin, click on Csap Management, we'll note that the Csap Admin service is already available. If we go ahead and launch the admin, this will give us access to all of the management agents. And now, if we switch to the Deployments tab, click on Backlog, we'll now see the entire cluster of hosts. In this instance, you can note that Csap Dev 7 was a little bit slower than the other hosts during the initial install. It's currently installing Docker, but Docker has already been installed on all of the other hosts. And just a quick review of how we can review logs of services being installed. We can click on Docker and then view the start deployment logs, and we'll currently see where it is at in the process. It looks like it just completed. And when we hit refresh, you can see that it went over to the events Mongo service. The alternate mechanism to see what the state of an installation is we can switch to services. And in this case, let's see how the Kubernetes is proceeding, since 4 of the nodes were showing that it was in progress. If we click on Kubelet, click on Logs, you can see that there's nothing happening on Dev 7. If we go to Dev 8, and click on Start, you'll actually see that there's something going on here. What's actually happening is that it is polling, waiting for the Kubernetes master to start. So once it's actually available, this node will kick off in parallel. Now we can see that the master install has kicked off on 07, so we can quickly flip back to the logs, switch to the kubelet start logs, and we can observe the installation of the master. Just to review, when installing Kubernetes with a multi-node cluster, the master must complete its installation first, as it is used as the seed for all the workers. So in this case, once the master has completed the installation, then the installations on all the other 5 remaining nodes will happen in parallel. Now it is worth noting that the Kubernetes images will be pulled down on the other remaining nodes, so that once this guy does complete off, then all those other nodes will proceed for. The final stages of the master install is waiting for the Calico networking to be available. Once it is available, the other nodes will all install concurrently. and it looks like that's coming up now, and it has completed on the master, and as shown here, it's waiting for the other nodes to complete their installation. We can monitor that progress simply by switching over to some of the other nodes and observing the output. So you can see that CSAP Dev 8 is coming along nicely, and it looks like 10 and 11 are almost there as well. On Dev 12, it looks like we're also in a near ready state. We'll stay and follow this one for a second, just so that you can observe the output of the logs. One of the key things that CSAP does as part of its install is to actually perform sanity testing on completion. So we're simply going to verify that we see that output. And sure enough, we actually did. It's completed the installation on 12. We can switch to the overall backlog and observe the final steps. In this instance, once Kubelet has completed its installation, we're going to see the installation of the NFS client, the ingress controller, the dashboard, metric server. And within about 10 minutes, the installation has completed on all 7 nodes. So what does this system look like? There's a couple of different ways to break this down. Starting with the host tab. The host tab reveals host being installed along with their core configuration, memory, cores, etc. There's a couple of interesting items, CPU test and disk stacks, which are essentially used to perform a validation of infrastructure to ensure that we're seeing more or less consistent infrastructure response across all of the systems. If we switch to the OS view, the OS reveals which version of the operating system is being used and any other summary information. If we switch to the Kubernetes perspective, the Kubernetes view will reveal the Docker version, the Kubernetes version, and other key elements. Let's try and dig a little bit more into what we just completed installation. The CSAP deployment view, of course, will reveal the services that are deployed and available on the system. The Kubernetes summary view is mostly a read-only view that acts to quickly give summary reports of what the system looks like. So in this example, we can quickly see the 7 workers that are part of the Kubernetes cluster. It is not necessary for all CSAP hosts to be in the Kubernetes view. It's only those nodes that have been selected. If we select the actual node, we can actually see more of the information from the Kubernetes inspector. We can also take a quick look at the pods, and you can see that we have a couple of namespaces added up. That includes the Kubernetes dashboard. The training section of the CSAP wiki provides a complete walkthrough of all the different features. For now, let's just quickly focus on things that were specific to this template install. On the deployment tab, there's a cluster named DCIB services. Selecting it reveals that an LDAP server and an NFS server have been installed. These essentially act as placeholders until teams choose to integrate their own enterprise hosted systems. Selecting the NFS server reveals that the NFS server has been installed on Csap Devo 7. The NFS server is being used as a storage provider to Kubernetes, and we can verify that by switching to the host view, opening up any one of these hosts. We'll go to Dev 10. We will be prompted for login because we have yet to configure the shared LDAP server. But let's go ahead, log in on Dev 10. We can switch to the file system view, and we can note that there's a file system NFS share, and NFS share is being mounted from Dev 7. Now, the Kubernetes NFS client does not actually leverage this mount point. It's mounted simply as a convenience feature for teams wishing to explore the system. If we switch to the OS Explorer, open the pods, we'll note that the NFS client provisioner is there. This will provide storage to any pods that require it. Let's go ahead and install the CSAP monitoring service, which will create a volume that verifies that NFS is provisioned correctly. To do this, I'm going to switch back to the admin host and select Projects, File View, and by default this is only showing the application definition. Let's go ahead and view all of the shortcuts on the system, including the platform. If we open up the autoplays and take a quick look at the CSAP monitoring autoplay, we'll note that there's a couple of setup steps. The key one is simply to confirm that your integration environment is correct. Assuming you did not modify the default installation template, the environment name is dev. And so we should be able to go ahead and execute this directly. To do so, I'll go ahead and select it, select the menu item next to it, and click Apply. We'll receive a message saying it went ahead and provisioned it. And so now if we switch to the environment view and we filter by monitoring, you can now see that a new service has been added to the Kubernetes provider cluster. If we switch to the Kubernetes provider cluster, we now see that we have this new package that can be installed. We'll go ahead and select it. All we need to do is hit the start button since the package is already on the host. Hitting start will actually go ahead, create new service monitors, install pods, and create a volume. The CSAP package monitor uses kubernetes as the backing service definitions. That's what's going on here. Looking at the navigation closely, you will have observed that the volumes have increased, as have the pods. Clicking on pods reveals a new namespace created called CSAP monitoring, and I delayed just long enough for all of those pods to quickly come into service. And this includes a volume which is stored on the NFS store. The default CSAP template includes some shortcuts added. So if we return to the landing page of the application, you'll see that we actually had Grafana, Alert Manager, and Prometheus. If we had clicked on these before performing the steps, they would have not been available. Let's go ahead and launch Grafana. And then we can quickly go look at the compute resources on the lab. Since this lab just installed now, you can see that the data is just starting to be recorded. And that's it. Just to circle back to where we started, we used a Docker image to start up the CSAP demo application. That demo application includes a library template that enabled us to quickly configure and install a 6-node Kubernetes system with an NFS server to provide storage management. We used the default CSAP credential, admin and password, to log into this newly installed admin on CSAP Dev 7. We can switch to using your enterprise hosted LDAP or the LDAP that's included with the CSAP DCIB services. So we have an LDAP server that can be used on all the hosts for single sign-on, or you can configure your own. To configure or change the application definition in CSAP, we of course go to the application definition and we need to modify it. In this instance, to modify LDAP, switch to the file view. To set up single sign-on, we'll open up application company. Since this is a generated file from the template, formatting is a little bit less than ideal, but we can space it out a little bit to make it a little bit more readable. The notes are kind of highlighted in the steps to enable. The first step, simply rename the existing provider and then switch to the open LDAP. and then we can go ahead and save it. In order for this configuration file to be used, we need to restart the services that require LDAP, which is the management agents and the admin. Prior to doing that, we can quickly verify the users that are installed in this LDAP instance. If we return to the Docker images on GitHub, select the CSAP platform, we can simply run using the credential listed here. So the admin user is this, and the pass is admin. Just to reiterate, this is the LDAP server. So let's switch to the deployments and launch the LDAP UI. Click on login, paste the login DN and the password. And again, just to reiterate, these are not CSAP users. These are the users for the LDAP server that CSAP packaged. Now we can see that we've got the default database that has been configured in that image. If we click on people, you can see that we have a user ID called admin, Bob, and a few others. There's an option in here to actually verify the password. So if we click on admin, click on check password, this will just verify that the CSAP admin user is admin and the password is admin. And it works. Now that we're confident that we have a running LDAP server, we have a password for logged in users, we can go ahead and verify that by restarting the agents. To avoid an accident, we'll just do it on one node first. Switch down to activate, and since we haven't checked this into Git yet, we'll go ahead and click on test. And it gives us the message that it's going to update the application definition on all of the hosts in our cluster. That completed now, let's return to the deployment tab, select CS agent, and go ahead and stop and restart that again. And again, within about 15 seconds, we've got those logs being regenerated. This time, when we look at the output, we now can see that LDAP has been configured and it's using the Devo 7 instance that we've provided. Again, once you've verified that LDAP is working correctly in your system, you can switch to your own enterprise store. To complete this use case, let's go ahead, switch to host, and now you'll see a login. And the key thing to note is that the provider is now Dev 7. We can verify our admin user with our admin password, and we logged in just fine. To assert these across all of the nodes, we simply go back to the agent, select all, stop, restart the agents. This will restart all of the agents and reload the application definition. It's critical to note that most of the changes you make to the application definition do not require a restart, only the entries in the application.yml file. And after hitting refresh a couple of times, I can see all of my agents are back up. The one other item that uses those entries is the admin service itself, which is what we're currently logged in as for the multi-node support. So if we go to the management cluster, and we'll quickly just do a quick restart on it. Important to note that while restarting the admin while logged into the admin is going to result in a temporary outage, the alternate workflow would have been to launch the agent, and then on the agent with the admin running on it, we would just hit the restart. And within about 15 seconds, I was able to reload the browser. Now, to verify that we now have single sign-on working, we'll go ahead, log out, verify that we've got LDAP. We're logged into the admin host, and the user ID is admin. It's important to note the default installation of CSAP, it's admin and password. But for the LDAP, it's admin and admin. So you can see that I actually had to backspace my recalled password. And just like that, we should now have single sign-on working across all of the hosts. And indeed we do. We can now launch to the agents on any host from the admin.